we've covered artificial skin in the past, the one thing that we've neglected? Can you tickle it? I mean, right, what fun is a robot if it can't kick in at the tickle party? So, researchers at the University of Bristol have created an interactive artificial skin. The skin-on interface is a multi-layer silicone membrane that mimics the layers in human skin. It consists of a surface textured layer, an electrode layer with conductive threads, and a hypodermis layer. It allows devices to feel your grasp, including tickling, caressing, even twisting and pinching. And that caption is on this photo with a robot being tickled, caressed, twisted, and pinched. Now, I know that they also created a phone case and a computer touchpad as part of the tech demonstration, but we all know where this is headed, right? Extremely realistic shaved cat robots. You can feel the cat purr as you caress its bald skin. I understand why you might miss the story. Most of the pictures just look like someone let their kid run wild at the lab with a tub of silly putty. Just covered everything. But the university, which collaborated with Telecom Paris Tech and Sorbonne University, also released a sizzle reel of various pinching, touching, tapping, and otherwise fondling. To control the phone. Next, the researchers are working on making the skin even more realistic, including embedding hair and giving it goosebumps. I think one of the authors of the paper said it best when they said, "This work explores the intersection between man and machine." I'd say you nailed it. Back in June, we watched as composite metal foam, or CMF, stopped armor-piercing bullets. Researchers fired a 50 caliber armor-piercing round 514 meters per second at the foam, and it bounced off. Now, researchers from North Carolina State University have a new, slightly less volatile application for the foam. Using a combination of CMF and epoxy resin, the team believes that they could revolutionize aircraft wing design, and really anything that uses aluminum. The hybrid material is called infused CMF. When we saw the bullet bouncing foam, it was made up of hollow spheres made of steel and titanium embedded into steel, aluminum, and other alloys. This hybrid uses stainless steel spheres and a stainless steel matrix. However, they immerse the material in a hydrophobic epoxy resin and use vacuum forces to draw resin into the hollow spheres and pores in the matrix. After the process, about 88% of the CMF's pores are filled with resin. What I found most interesting is how they tested it. In order to stand up to aerospace grade aluminum, they needed to see how quickly water streams off of it, how well it stands up to erosion, and how well bug parts stick to it. Really? In all tests, the infused CMF performed better than aluminum. Even the bug test, which not only tests the maximum height of bug residue that builds up on the material, but the total area covered in bug guts as well. How do you test that? It could help cut costs of future aircraft design by improving performance while cutting the all-important weight and improving fuel efficiency. And it's better on bugs. Well, you get it. NASA's Artemis program wants to put Americans back on the moon by 2024, but the program has had its share of problems. The $20 to $30 billion price tag has ruffled some feathers, not just on overall cost, but who will land the contracts and how they're going to be used. The program has some aggressive goals, including building an outpost on the moon and mining for resources. It has also been considered that Artemis would be the precursor for a mission to Mars. This week, Artemis took one step closer to becoming a reality as Blue Origin announced a national team that will build the human landing system that will be used to reach the moon. And it is a supergroup, like the Avengers, only as long as they were all aerospace engineers, like a group full of Banners and Starks. I mean, I'd still watch that. Blue Origin signed agreements with Lockheed Martin, Northrop Grumman, and Draper. Each company has experience working with NASA and has expertise in elements crucial to the program's success. Draper will lead descent guidance and provide flight avionics. Northrop Grumman will provide the transfer element vehicle that brings the landing system towards the moon. Lockheed Martin is heading up the reusable ascent element vehicle and also heads up the crewed flight operations and training. And Blue Origin, the prime contractor, will lead program management, systems engineering, safety and mission assurance, and mission engineering, while also providing the descent element that is based on the multi-year development of the Blue Moon lunar lander. Blue Origin says it's time to go back to the moon. This time, to stay. I'm David Manti. This is Engineering by Design.